Hello everyone and welcome back to the GoFr channel. I'm Divya Darshana and today we are going to explore how GoFr makes it effortless to work with multiple data stores in modern applications. We'll see how GoFr streamlines connection management using a single context and keeps your application lightweight with its plug-and-play model. Stick around till the end of the video for a quick demo of seamlessly integrating one of the multiple data sources that we support in GoFr. So let's not waste any more time and let's get coding with GoFr. Modern applications often leverage multiple types of data stores within a single microservice to handle diverse requirements. For instance, you might use Redis for caching, SQL databases for structured data storage, and S3 for storing images in your microservice. Managing these connections, initializing them, and making them available where needed can be a complex and a repetitive task. GoFr addresses this challenge by introducing a single context that encapsulates all the database connections initialized in your application. This unified context simplifies connection management, ensuring that all resources are easily accessible wherever they are required. And despite this convenience, GoFr manages to keep your binaries build size compact, because each database integration is actually externalized into a separate package which is only imported when explicitly used in your application. This ensures that your application remains lightweight while still offering robust flexibility to work with multiple data stores seamlessly. Currently, GoFr supports data sources like MongoDB, Cassandra, ClickHouse, dgraph, BadgerDB, OpenTSDB, SkylarDB, and Solr. For file management, GoFr provides a unified interface across file systems like FTP, S3, and SFTP. This developer-friendly interface eliminates the need to remember different commands or syntax for tasks like reading, writing, creating files, etc. In the upcoming videos, we'll explore how to seamlessly handle files within your GoFr applications, including best practices for storage, retrieval, and more. And in this video, we'll build on the project that we have already worked on, the one where we had previously set up the HTTP server with routes like hello and SQL. Today, we'll extend it to connect to one of our external data sources, that is MongoDB. But before we get started with coding, let me walk you through a few setups that you need to complete beforehand. So the prerequisites include, we must have Docker installed in a system because we are going to use it to run a MongoDB instance. Once Docker is up, we need to spin a MongoDB container and create a test database. Then we make a table named users in a database. We also must have Postman installed because we are going to use it to send GET and POST requests to test our APIs. One of the best part about GoFr applications is how simple it is to connect to your data sources by just providing the necessary data source configurations. To find the detailed instructions, let's head over to our official website gofr.dev. So we go to gofr.dev and then get started. Then we navigate to advanced guide and check out the section on injecting databases. Now this section has the examples of all the database packages and even a quick code snippet to help you set things up. As we will be connecting to MongoDB, we head over to the MongoDB section, and as we can see, the documentation helps us with the methods that we can call on our MongoDB client. So let's go back to our HTTP server project. As I have mentioned before, MongoDB support is externalized in GoFr. So to fetch the required module, we go to the terminal and run the command go get gofr.dev/package/gopher/datasource/mongo@latest to fetch the latest version. And that's it. The module is now the part of our project. Now to configure the connection and actually connect to MongoDB, we first need to define configs, that is mongo.config, and we give the host, port, user, password, and database. This is now passed to mongo.new, which returns a Mongo client. Now we can call the method on app, that is addMongo, as app.addMongo and pass the client that was returned by mongo.new. And this is all the code you need to get connected to MongoDB. No fuss, no complications. Moving ahead, we'll create a handlers. Now we'll implement two handlers today. First is going to be insert user and the second is going to be get user. Insert user will handle post request to insert new user data into MongoDB, and get user will handle get request to fetch user details by their name. Let's start with the insert user handler. This is where we'll send user data via a post request and insert it into MongoDB. But first we need to define a person struct to represent our user data as type person struct with fields as name of string type and age of int type. Notice the JSON and BSON tags here. The JSON tag helps bind incoming JSON data to this struct, and the BSON tag ensures MongoDB can store the data in its document format. So in our defined handler, that is insert user, we'll first declare the variable user of person type. Then we bind the incoming JSON data to the struct and check for the error. So if error is not equal to nil, then we return nil and error. And then we will execute the DB call. As we are just adding the data of one user, we will write ctx.mongo.insert1, which takes the context, the name of the table that is user, and then the user struct. This method returns response and error. We'll check for the error, that if error is not nil, then we return nil and the error. And if error is nil, we'll go forward and write return response and nil. Let's move on to our get user handler. This handler will fetch user details by their name, which we will send as a query parameter. So in our get user handler, we again define a variable result that is of person type. We will first fetch the name query parameter, that is name assigned as ctx.param, that takes the query name. And then we will go forward and query the database for the user as ctx.mongo.find1, that takes the argument context, the name of the table that is user, and bson.d with key as name and value as the name that has been fetched. Now this function actually takes a pointer to the variable where you would like to bind the returned response and returns an error. So we'll check for error, as if error is not equal to nil, then we return nil and error. And if it is equal to nil, then we return the response, that is result, and nil for the error. As we have defined both of our handlers, it is time to test our API using Postman. So we will first go to the terminal and write go run main.go. And as our server runs, we can see the logs in our terminal that we are successfully connected to MongoDB. So we move ahead to test in Postman. Now we'll first start with a post request to insert the data of a user. The URL that we'll be hitting is http://localhost and the port, that is 8000, on which our HTTP server is actually running, /mongo, because we have defined a post method on /mongo endpoint to insert a user. In the body, we'll send the name as John Doe and age as 30. And we click on send. And we see that we get a response. Now let's test the get method defined on the same endpoint. So in the URL, we add question mark name equal to John %20 Doe. Here %20 is for space. Now we again hit send, and as you can see, we are successfully able to fetch the details from the MongoDB database. Abstracted and efficient REST handlers, 12-factor app configuration management, and externalized multi-database support. Is that it to build a production-grade application? Your application might start small and easy to understand, but as features are added and the code base expands, things starts to get messy. Functions call each other, dependencies tangle, and suddenly pinpointing the source of a bug or identifying performance bottlenecks feels like searching for a needle in a haystack. This complexity can lead to unpredictable performance where users experience frustrating delays and your application's reputation takes a hit. Debugging and maintenance nightmares where you're spending hours chasing phantom bugs, jumping from one function to another without any clear direction. And even making minor changes becomes risky, fearing unintended consequences. So how do we tackle this? Well, in the next video, we'll dive into the world of observability and help you find the answer to this very question. We'll explore the 3 pillars of observability, that is logs, traces, and metrics, and see how these pillars work together to provide a comprehensive view of your application's health, allowing you to proactively identify and resolve issues before they impact your users. In the meantime, check out our open source code at github.com/gopher.dev and explore our documentation at gopher.dev for more examples and beyond. If you found this video helpful, don't forget to like, subscribe, and share it with your peers. Drop a comment below with your thoughts, and I'll see you in the next one. Until then, happy coding with GoFr.